I'd like to give my own overview of what this lab is meant to achieve. First off, we're studying a reaction uh, involving an indicator. This is an acid-base indicator. This substance has a color associated with it and a color change upon losing its hydrogen. And so here you see the original species that will abbreviate H indicator. That's indicator with the hydrogen attached, has a -1 charge. Then on the product side, we have a hydrogen cation, H plus 1, and the -2 charge species that we'll just call the indicator. The equilibrium constant expression for a reaction like this would put the products in the top, the reactant in the bottom, and raising each to their stoichiometric coefficients, and all of the coefficients are 1. So the lab is about determining this equilibrium constant, and so we will prepare several different solutions, and we will measure each of these three quantities and then compute the equilibrium constant from it. We'll do it for 3 different samples, and then you can average the value to report a final equilibrium constant. Each of these quantities can be obtained in a different way. Let's start first with the hydrogen ion concentration. Because we can put a pH meter probe in the solution, we can measure the pH, and from the pH, by taking 10 to the power of negative pH, we will be able to compute the hydrogen ion concentration. The indicator, the deprotonated species, has a color associated with it, so we can measure the absorbance at an appropriate wavelength and be able to make a connection between the absorbance and the concentration. Now that connection is through this proportionality constant B. We will do a first preliminary experiment with a known concentration of the indicator in order to obtain what the value of B is. And then, with our equilibrium solutions, we'll be able to use that value of B and the measured absorbance to compute how much indicator is present. The third and final quantity we can get by difference, because we know, for instance, how much of the protonated indicator we start with, and if we know how much of the deprotonated indicator is present from the absorbance measurements, we can subtract off that amount, because this is a 1-to-1 ratio here in terms of the stoichiometry. So the initial amount put in minus the amount of indicator present will give us the number to put here in the concentration of the denominator. Now let's take a look at the simulation for this lab. This is an Excel spreadsheet that you can download from the Canvas, and notice that we're using for our work here a 0.0012 molar concentrated stock solution for the indicator. That's the species that we'll add here where it says stock solutions. In steps 5 through 11 of the procedure, what you would have done in lab is to prepare a stock solution where we've forced the indicator to be in the deprotonated state, the IN double minus. And you do that by pouring out some of the stock solution, adding some sodium hydroxide pellets, and then filling up our volumetric flask, which is 100 milliliters, to the line with water. And then that's the solution that you would measure the absorbance of. So beginning with this stock solution, let's say you put in 1 milliliter of the solution, and add 1 pellet would be enough for the sodium hydroxide, and we're going to fill up the flask for a total volume of 100 milliliters. The absorbance now is shown here. That's the absorbance that would have been given to you on the spectrometer if you took that solution and measured its absorbance. So we'll use that part of the lab to determine the value of B. I will also note that this document lets you play around a bit with the lab. You don't have to follow exactly the procedure. Uh, and for instance, suppose you wanted to use 2 milliliters of the stock solution. Um, that is perfectly fine. That gives you a different absorbance value. It'll give you the same B value though, because these volume of stock and the absorbance is directly proportional. Likewise, down in the steps 12 through 16 of the procedure, you're asked to prepare 3 different solutions, and they will have different amounts of the 3 species that we're calculating the equilibrium constant using. And you can use the suggested amounts that's given in the lab write-up, and then the total volume should be 100 again. And after you enter all of these numbers, you'll see the absorbance and pH values computed for you. And that's as if you were to make those solutions, measure the absorbance, measure the pH. That's what you would have found in the lab. Again, with this, you can use the exact numbers if you want, or you can vary it slightly. There's no reason you can't use a little bit more or a little bit less of any of these solutions. You will get the correct absorbance and pH values from the simulation. After you've completed all the cells here and recorded all of your data, that's all you need for the analysis of this lab. When it comes to doing the analysis, writing the report and submitting it, if you run into any difficulties, if you have any questions, please reach out to me. I can reply to an email, or if you want to have a video chat, we can use Zoom and you can show me your work. I can help you through some of the analysis if you need help. Don't be afraid to ask.